All right, the sum of a number divided by 2 and the number divided by 3 is 10. What is the number? All right, so that's going to be the question. So we're looking for a number. So let's just write that, let's call the number something. How about n? Getting used to that? Okay, now the sum of a number divided by 2 and the number divided by 3. All right, we're adding two things together, right? Because we're taking the sum of two things and we're going to get 10. So we know we're adding two things together and we're going to end up with 10. Okay? Now what are we adding together? Well, we're taking the sum of what two things? The number divided by 2, and there's that keyword and the number divided by 3. Right? The sum has to have two parts, and it's separated by the sum of one thing and the other thing. So the first part will be a number divided by 2. Now remember, in algebra, we write that with a fraction. So that'll be the number over 2. That represents the number divided by 2. What's the other part of the sum? The second thing is the number divided by 3. So n over 3. So that's the equation. Now there are different ways of solving an equation with fractions in it. I like doing it by multiplying both sides by the least common denominator. So what's the least common denominator when you have a 2 in the denominator and a 3? Hopefully you know that's going to be 6. So I'm going to multiply both sides of the equation by 6. So in other words, I'm going to do everything by 6. I'm going to distribute that 6 to everything. So I'm going to have a 6 over 1, if you like to see it that way, times my n over 2, plus 6 over 1 times n over 3. And what I mean is by each term on both sides of the equation when I say everything. And 6 over 1 times 10 over 1. Right? You do not have to write 6 over 1 or 10 over 1. You could just write the numbers as they are since they're whole numbers, but I'm doing it for people who like to see everything in terms of fractions, easier for them to see the numerator and denominator. Okay, so let's see. For this first product, because I'm just doing order of operations, remember we do multiplication before we add? So I'm going to cancel, and I'm going to get 3n over 1, which is just 3n. Remember the reason we multiply by the least common denominators, we are going to eliminate all of the fractions. So we won't have any fractions. You should end up with all ones in the denominator, which means you'll just have whole numbers. All right, now the second one, 6 times n over 3. The 3 cancels, and I'm going to get a 2, right? So I have 2 times n over 1, which is just 2n. And 6 times 10 is just going to be 60, which is the same thing as 60 over 1, of course. So that's a technique I use to solve the equation because I want to eliminate the fractions in the first step. All right, now what do we do at this step? Well, I need to simplify the left-hand side by adding 3n plus 2n together. And then I'm going to divide both by 5, right? Running out of space. So that I get n equals 12. So it looks like the number is 12. All right, now let's go back and remember what the original problem was. Okay, the original problem stated the sum of a number divided by 2 and the number divided by 3 is 10. And then we found the number, and it looks like the answer is going to be 12. But let's make sure. If it's 12, we're going to do the sum of the number divided by 2. Okay, so we're going to add two things, right? So here's my check. We're adding two things. We take the number divided by 2. All right, well, what's 12 divided by 2? 6. All right, and then we're adding that to the number divided by 3. Okay, so if the number is 12, what's 12 divided by 3? 4. All right, when you add that together, you get 10. All right, and it said that the sum, when I did that, should add up to 10. So yes, the answer is 12. So the number we're looking for is 12. Here's another age puzzle. 6 times Dylan's age is 40 more than twice his age. How old is Dylan? I'm doing this for my nephew Dylan. All right, so let's say we don't know what Dylan's age is. So let's call his age, how about D, big D for Dylan. So 6 times his age is, okay, see that word is, that's going to be our equal sign. So on the left-hand side, we're going to have 6 times D. That'll represent 6 times Dylan's age. And that is going to be 40 more than twice his age. So we're going to add 40 to something, remember? We're going to add it to twice his age. Twice something means 2 times. So if his age is D, that'll be 2D. So we've got 6D equals 2D plus 40. And that is our equation. Oh, my D's look kind of funny there. I didn't know I wrote them so slanted. Okay, so now we're going to subtract 2D from both sides. So we have both D's on both sides of the equation. I'm sorry, so we have the D's on the left-hand side of the equation. So that gives us 4D equals 40. And now we can divide both sides by 4 to get Dylan's age. All right, so D is 10. Remember, we're asked for how old he is. We don't want to leave that as D equals 10. We want to say Dylan is 10 years old. Okay, let's check it because easy to make a mistake, so it's always good to go back to the words and see if it makes sense. All right, so let's assume I got it correct. Dylan's 10 years old. It says 6 times Dylan's age is 40 more than twice his age. Well, what's 6 times his age? 6 times 10 would be 60. Now, is that 40 more than twice his age? Well, what's twice his age? 2 times 10 is 20. Then I have to add 40 to that. And I also get 60. So, yep, it checks out. And Dylan is 10 years old. The temperature equals its opposite added to 144 degrees. Find the temperature. All right, we're looking for temperature, so let's begin by defining temperature with a variable. So why don't we call it T for temperature. So what do we have here? The temperature equals, okay, so the temperature is T, so I could write T equals its opposite added to 144. So I'm adding its opposite to 144. Well, so I've got 144, and then I'm adding its opposite. What's its opposite? What does that mean? Well, if the temperature is T, its opposite is negative T. So I'm adding negative T, if you want to write it like that. Now, you could have also written this as negative T plus 144. That's up to you. All right, so I have the variable on both sides of the equation. So let's add T to both sides so that I have the variables on the left side. And now I can just divide by 2 so that T is 72. But remember, we want to do that in terms of degrees. So the answer would be the temperature is 72 degrees. Now let's make sure this makes sense. We do need to check it. It says the temperature, well, let's say it's 72. Is that the same thing as its opposite added to 144? So if you've got 144 and you add the opposite, you're adding negative 72 degrees, right? So basically it's 144 minus 72 is 72 degrees, which really is the temperature. So looks like we did it correct. The temperature is 72 degrees.